Why is bit resolution crucial for analog to digital converters? Imagine trying to capture the subtle shades of a sunset with a camera. If your camera only has a few color options, the picture will look dull and less detailed. The same idea applies to converting signals from the real world into digital data. When we talk about analog to digital converters, or ADCS, the key factor that determines how well they do their job is called bit resolution. Bit resolution is the number of binary digits, or bits, that an ADC uses to representing each sample of an analog signal. Think of it like the number of shades of gray a black and white image can display. An 8-bit ADC can produce 256 different digital values, while a 16-bit ADC can produce over 65,000. The more bits an ADC has, the more precise the digital representation of the analog signal will be. This precision is important because it affects the smallest change the ADC can detect in the input signal. This smallest change is called the least significant bit. For example, if you have a 5-volt range and a 10-bit ADC, the least significant bit is about 4.88 millivolts. That means the ADC cannot tell the difference between two signals that are less than 4.88 millivolts apart. If you need to measure tiny variations, higher resolution is essential. Higher bit resolution also means less quantization error. Quantization error is the difference between the actual analog value and the digital value the ADC assigns. This error introduces noise and distortion into the digital signal. When the resolution increases, the quantization error decreases, leading to a cleaner, more accurate digital output. This is especially important in applications like audio recording, scientific measurements, and control systems where accuracy matters a lot. In data collection systems used in industry or research, higher resolution allows for more detailed measurements. For example, measuring water levels in a tank with a 10-bit ADC gives you 1020 for steps, but an 11-bit ADC doubles that to 2048 steps. That extra resolution can make a big difference in how precisely you can monitor and control processes. However, it is not always better to have the highest resolution possible. Higher resolution ADCs tend to be more complex, cost more, and may operate more slowly. They also consume more power, which can be a concern in battery-powered devices. Engineers need to find the right balance between resolution, speed, cost, and power for each specific application. In summary, bit resolution is a fundamental part of ADC design because it determines how accurately the analog signal is represented in digital form. It influences measurement precision, noise levels, and overall signal quality. Choosing the right resolution ensures that electronic systems work reliably and produce meaningful data.